So this is the part of the presentation or slides that I wasn't able to talk about in class the other day for it4100 about partitioning. I think we got to this slide, so we were talking about partitioning. So some of the questions you ask when you partition is, how many partitions can I have? How many do I need? Is a drive equal to a partition? Is a partition equal to a drive? I think we've addressed maybe those last two, and certainly for a Windows machine, if you partition a disk, the operating system does think it's another drive, so it'll show up as drive C or drive D. And so for all intents and purposes, the operating system does see a partition as a separate drive. But those other questions deserve a little bit more exploration for how many partitions can I have and how many do I need. To understand that topic, we need to look at the master boot record. And the master boot record is a very important partition. It's always located on the first sector of a hard disk. It contains the disk's master partition table, or in other words, it contains information about how the disk is partitioned, how it's laid out, how we've carved it up. It also contains information on what should the system boot next. So it will go find where is the bootable partition. In Linux, this might be stage 1 of grub. And we will talk a little bit more about the boot process later. So here is an image that I found that kind of gives just an overview of what the master boot record, or sometimes we also call this the DOS partition table, what it actually is. And so you can see the first 445 bytes contain boot code, and then we have our partition table entries. And notice there are 4 partition table entries which are allowed, and this is going to kind of line up to our 4 primary partitions. We talk about that in a minute. We don't have to memorize all this, by the way. Just interesting to see. Then inside of this DOS partition table entry, if I explode one of those, we can set whether it's bootable or not. We can set what type of partition it is. We can set how big the size of the partition is. Once again, you don't need to memorize this, and we'll see this later on as we carve out some partitions. But the master boot record has some problems. The maximum addressable storage space is 2 terabytes, approximately. And this was great. It's worked well for the past, 20, 30 years. But now that disk drives are becoming larger than 2 terabytes, the master boot record really isn't going to cut it anymore. So slowly the master boot record, or sometimes I call it the DOS partition table, is being superseded by what's called the GUID partition table, which we will talk more about later. So some more details about the MBR. Master boot record originally supported up to 4 primary partitions. Now they came out with several revisions later. It allowed one of those partitions to be used as what's called an extended partition. And within that extended partition, you could create any number of logical partitions. Now, I say any number, but there really was a finite number again. And, as soon as you start getting more than half a dozen partitions, you're really into the realm of research, or you're just doing something stupid that really doesn't need to be done. But anyway, there are finite limits to all these. So let's explore the primary versus logical. So one primary partition of a hard drive may be subpartitioned. That is what we call a logical partition. And so the primary partition used to house that logical partition is called an extended partition and has its own file system type. Unlike primary partitions, logical partitions, remember those partitions within the extended partition, have to be contiguous, or the blocks have to be next to each other. And each logical partition contains a pointer to the next logical partition, which implies that the number is unlimited, but it really depends on your hardware. So at most 15 partitions total if we're dealing with a SCSI disk, and 63 on an IDE disk. If you don't know what those disks are, you can do a quick search. Basically, it's just the way that the hard drive is attached to the motherboard. In Linux, at least one partition is required, whether it's primary or logical, for the root partition. This verb mounting is the action of connecting a file system to a particular point in the root file system. For example, when you plug in a thumb drive, it needs to show up somewhere so you can copy or do whatever you're going to do to it. So mounting is this idea of making it show up in your file system tree. Quick overview of device naming conventions. So once again, depending on the hardware that we're actually using, will determine what our device is going to be named. Once again, in the Linux realm. If we're dealing with an old IDE drive, which I haven't seen for 10 or 15 years, they will be showing up as /dev/HDA, or if it's the second IDE drive plugged in, it would show up as /dev/HDB. If it's the third IDE drive, it would show up as /dev/HDC, and so forth. And then in turn, you can subpartition those. So for example, if it was the first partition on the first IDE drive, it would show up as /dev/HDA1. If it was the second partition on the first IDE drive, it would show up as dev/HDA2. SCSI drives would follow a similar convention, except they would show up as SDA or SDB, depending on what number the SCSI drive is plugged in. SATA drives will show up like SCSI disks do. A couple of the tools we'll use throughout the semester, just to throw them out there to you, are Parted, FDisk, SFDisk, CFDisk. All these are used to manipulate and control the partition table inside of Linux, and we'll get to those later. So once we have partitioned the disk, then we can choose the way it should be formatted. So we need to specify how do we want our data organized on the disk. And there's lots of types to choose from. You perhaps have heard of NTFS or FAT, FAT32, FAT16, VFAT, ext4, ButterFS, HPFS, HFS. Anyway, there's a lot of different ways of formatting the file system, or the format controls how the data is actually laid out on the file system. And so there's some examples of those, and we'll experiment with a few of them later on. The difference between a disk or partition and the file system it contains is important. So a few programs operate directly on the raw sectors of a disk or partition. If there is an existing file system there, it will be destroyed or seriously corrupted. Most programs operate on a file system and therefore won't work on a partition that doesn't contain one. Well, okay, let me see if we can explain that a little bit better. So like Microsoft Word, for example, if you save a document to your disk, it will not save one unless there's a file system already created on it. Period. So you have to create a file system. But there are a few programs that will operate directly on the raw sectors of a disk or partition, and it will wipe out any blocks or file systems that are there. And when we format running the mkfs command, that's an example. That's operating on the raw sectors of a disk or partition. So we'll see that as well. Okay, so before we can use a disk, we need to format. We already said that. We're going to set up a logical disk structure. We use the mkfs command. I have some screenshots later on that show you how to do this, but we can use a program like CFDisk to partition the free space. We'll run mkfs to format the file system. We'll create a mount point by using mkdir command that will make a directory for us in Linux, and then we will run the mount command that would then mount that partition, dev sdb5. So in this case, that would be the fifth partition on my second SCSI disk. 2, it will mount it to the test mount directory that I just created, and then we could then cd into that directory, put files, and they would be stored on that partition. And that's it.